B is the function of x. 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 Define an interval. Define on an interval. I is subset are equal to capital R. Subset are equal to capital R. Subset are equal to capital R. So we denote differential expression on the left side of the equation 1 by, we denote 1 by L of y. L of y. L of y. Then equation 1 becomes, then 1 becomes one by, then 1 becomes 1 becomes 1 becomes that 1 becomes L of y equal to B of x. L of y equal to B of x. We denote LHS. So if B of x equal to 0, if B of x equal to 0, B of x equal to 0, for all x in I, for all x in I means interval. L of y equal to 0 is called L of y equal to 0 is called homogeneous equation. Homogeneous equation. Homogeneous equation. Homogeneous equation. Homogeneous equation. Homogeneous equation. So if B of x is not equal to 0, if B of x is not equal to 0, B of x is not equal to 0. For all x belongs to the interval I, L of y equal to, then L of y equal to B of x. L of y equal to B of x is called non-homogeneous equation. Is called non-homogeneous equation. Non-homogeneous equation. Non-homogeneous equation. A solution of L of y equal to B of x is a function of f of x. A solution, SOLN means a solution of L of y equal to B of x. L of y equal to B of x is a function of pi of x. expression of phi of x. Having nth order derivative, having nth order derivative, nth order derivative, nth order derivative on I, on interval I, such that ST means such that L of pi of L of pi equal to B of x, equal to B of x. B of x. So page number 186. Page number 186. All of you for the page number 186. If B of x is continuous on I, if B of x CTS means continuous on an interval I, it is possible to find all solutions of, it is possible to find all solutions of L of all solutions of L of y equal to B of x. 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 So 9 point. Differential operator and some of its properties. Next concept is differential 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 operator differential operator and some of its properties and some of its properties some of its properties some of its properties some of its properties some of its properties. We denote the differential operator. We denote the differential operator. DO means differential operator. D by dx by capital D. D by dx. D by dx by capital D. Capital D. And the differential operator in the DO. Yes, means differential operators. D square y by dx square. D square by dx square. D cube y by dx cube. Dx cube. Dx cube. D power n by dx power n. Dx power n. dx power n. That equal to, this can be written as d square, comma, d cube, comma, so on, capital D power n, respectively, when applied on the function y of x. When applied on a function, when applied, when applied, when applied on a function, on function, on a function y of x, y of x, y of x. These operators yield, these operators yield yields dy, dy, dy equal to dy by dx, dy by dx, d square y, d square y is nothing but d square y by dx square, d square y by dx square, d square y by dx square. So dn, d power n y equal to d power n y by dx power n, dx power n, dx power n. A polynomial in D, for example, a polynomial in D in D, example, EG means example, d power n, d power n plus a1 plus a1 d power n minus 1 plus a2 d power n minus 2 d power n minus 2 plus so on, plus so on. an, an, an denoted by ft is denoted by f of d, denoted by f of d. That is nothing but you can write f of d equal to f of d equal. When applied function of y of x, f of d becomes, f of d becomes, when applied to a function, when applied to a function, y of x, y of x, y of x. So f of dy, f of dy, f of dy equal d power n, d power n y plus d power n plus a1, a1 d power n minus 1 into y to y plus so on, plus so on, plus so on. an y. This is nothing but we can convert d power n y by dx power n plus a1 d power n minus 1 y divided by dx power n minus 1 plus a2 d power n minus 2 y divided by dx power n minus 2 plus so on a n y that means so we apply the notation if we apply the notation d power k of y divided by dx power k where k equal to 1 to n where k equal to 1 to n where k equal to 1 to n f of dy equal to the equation 1 becomes the equation 1 becomes the equation 1 becomes f of dy equal to f of dy equal to b of x yes, which is called operator form of 1 which is called operator form of 1 operator form of 1 operator form of 1 operator form of 1 operator form of case 1 if b of x equal to 0 if b of x equal to 0 for all x interval f of dy is called linear homogeneous equation of order n. That implies f of dy equal to 0 is called linear. L means linear. Homo means homogeneous. DE means differential equation. Homogeneous equation of order n. Okay, for example, d square y by dx square d square y by dx square dx square minus 4 dy by dx plus 2y equal to 0 plus 2y equal to 0 This can be written as d square y minus 4 dy 4 dy plus 2y that equal to 0. Or we can write to take y as common. That becomes d square minus 4d plus 2y that equal to 0. Which is a linear homogeneous equation of order 2. Which is a linear homogeneous which is a linear homogeneous HOMO means homogeneous equation of order 2 of order 2 case 2 case 2 case 2 if b of x is not equal to 0, if b of x is not equal to 0, so for some x in the interval I, then fd of y equal to bx is called linear non-homogeneous equation. Is called linear non-homogeneous equation. Non-homogeneous equation. Example. 5 d square y by dx square 5 d square y by dx square plus 3 dy by dx dy by dx dy by dx minus 4y equal to sin 2x. Sin 2x is a non-homogeneous equation of order 2. Non-homogeneous equation of order 2. Next, page number 190. Page number 190. And if you follow page number 190 of your textbook. General solution of a second order homogeneous equation. GS means general solution of second order homogeneous equation. Second order homogeneous equation. O means homogeneous EQN equation. L of y equal to FD of y equal to 0. L of y equal to FD of y that equal to 0. So consider the homogeneous equation order 2 L of y equal to means let L of y equal to d square y by dx square d square y by dx square, d square over dx square, plus a1 dy by dx, a1 dy by dx, plus a2y equal to 0, a2y equal to 0. Consider equation number 1. Right? Consider equation number 1. Using D, using means differential operator, D equal to d by dt, d by dx, d square equal to d square equal to d square by dx square, d square by dx square. 1 becomes, so 1 becomes, means 1 converted as d square by plus d square by plus a1 dy, a1 by plus a2y, a2y equal to 0. We can convert this equation d square plus a1d plus a2 into y equal to 0. Equal to 0. That implies fd of y equal to 0. Equation number 2. Equation number 2. So we note that y equal to pi 1 of x is a solution of equation number 2. Let y equal to pi 1 of x is solution of 2, is solution of 2. Then C pi 2x, then C pi 2x, C pi 2x, where C is an arbitrary constant, where C is an arbitrary constant, arbitrary constant. Arbitrary constant. Arbitrary constant is also a solution. This becomes is also a solution. This because f of d c pi 1 that equal to c f of d pi 1 equal to 0. Here f of d is a linear operator. Here f of d is linear operator. Linear operator. F of d is a linear operator. Linear operator. Pi 1, pi 2 are the solutions of pi 1, comma pi 2 are solutions of equation number 2. Equation number 2. So that becomes that becomes f of d, f of d, f of d, c pi 1 minus c2 pi 2, c1 pi 1 plus c2 pi 2, c2 pi 2, that equal to c1 f of d pi 1 plus c2 f of d pi 2. That means that becomes c1 into 0 plus c2 into 0, that equal to 0 to 0. That means f of d pi 1 equal to 0. Since f of d, since f of d pi 1 equal to 0, f of d pi 2 equal to 0, pi 2 equal to 0, pi 2 equal to 0. So definition. What is the definition here? If phi 1, phi 2 are the two independent solution of equation number 1, if phi 1, comma, phi 2 are independent solutions of equation number 2, then y equal to c1 pi 1 plus c2 pi 2 is called general solution of primitive of equation 2, is called GS, means general solution of primitive of 2, equation number 2. This general solution of homogeneous equation is called homogeneous equation is called complementary function. What is that? Complementary function. CF means complementary function. CF. Page number 190. Follow, all of you students, follow page number 190. Right. Next. Here, case 1, case 2. Case 1, what is there? Auxiliary equation. So, this R square A1, A1R plus A2 equal to 0. That is equation number 3. Two real and distinct R1, R2, pi 1 of e power R1x plus pi 2x equal to e power R2x. Case 2 is auxiliary equation 3 has two roots equal and real or repeated. Next, case number 3, auxiliary equation 3 becomes imaginary, complex roots. Complex roots, what we will write? C1 e power alpha plus I beta x plus C2 e power alpha minus x beta x. Okay. So, page number 192. Page number 192. We'll discuss example 9.3.4. Page number 192. Page number 192. Example 9.3.4. Example 9.3. Solve d square y by dx square, d square y by dx square, d square y by dx square, minus 5 dy by dx, 5 dy by dx, dy by dx, plus 4y equal to 0, plus 4y equal to 0, 4y equal. So the auxiliary equation of 1 is solution. The auxiliary equation, auxiliary AUXI LIARY, auxiliary equation. Consider one auxiliary equation. Equation of 1 is r square minus 5r plus 4 equal to 0. 4 equal to 0. On solving the equation, the roots are solve the equation. Solving the equation. Solving the equation. Roots are r1 equal to 1 and r2 equal to 4. R2 equal to 4. Hence, pi 1x equal to means complementary function. Hence, pi 1 equal to pi 1 of x. Pi 1 of x equal to e power x. E power 1x means x e power x. And pi 2 equal to pi 2 of x equal to e power 4x. E power 4x. X are the solutions of given equation. Its complementary function. It's a CF. CF means complementary function. Generally, we denoted by y equal to C1 e power x plus C2 e power 4x is the solution of given equation. Next. So, concept 9.4, page number 193. Page number 193. 9.4 concepts. Linear dependence. Linear dependence. Linear dependence. Independence. Independence. And the Wronskian. Wronskian. And the Wronskian. Definition. Two functions, phi 1x, phi 2x, defined on interval I. Two functions, Fn Smith functions, phi 1x and phi 2x phi to x, phi to x. Define an interval defined on an interval define an interval I are said to be linearly dependent, said to be linearly dependent, dependent dependent. LD means linearly dependent on I means interval. There exist two constants. There exist two constants C1 comma C2 comma C2, not both zero, not both zero, both zero, such that ST means such that such that such that such that such that such that ST means such that C1 pi 1x C1 pi 1 of x plus C2 pi 2 of x equal to 0. For all x in I, C1 C2 equal to 0. For all x in I. Enter. Next definition. Next definition. The function pi2, pi1 and pi2 of x define an interval is said to be linearly independent. They are not linearly dependent there. The functions FNS means the functions pi1x comma pi2x defined on an interval I are said to be linearly independent. Linearly independent. Linearly independent. LI denoted. L capital I. Linearly independent. If they are not linearly dependent, they are not LD means linearly dependent. linearly dependent. If there exists content C1, C2 such that if there exists contains C1, C2 such that C1, C2 such that all are zero. Such that C1 phi1 of x plus C2 phi2 of x, phi2 of x, phi2 of x equal to 0. That implies C1 equal to C2 equal to 0. C1 equal to C2 equal to 0. Okay. So definition, Wronskian. Definition. Definition. If phi1x and phi2x are two solutions, if phi1x and phi2x are two solutions of differential equation, two solutions of DE means differential equation. L of y equal to y double dash, L of y equal to y double dash plus a1 y dash plus a1 y dash plus a2 y double dash y dash y that equal to 0. Then Wronskian of phi1 phi2 denoted by Wronskian of phi1 comma phi2 denoted by phi1 comma phi2 denoted by W of phi1 comma phi2 is defined as is defined as is defined as Wronskian of phi1 comma phi2 that equal phi1 comma phi2. Phi1 means phi1 of x meaning phi2. That is phi1 dash means differentiation of phi1. Phi2 dash differentiation of phi2. That equal to by cross multiplication phi1 phi2 dash minus phi1 dash into phi2. right? This function of value of x is denoted by Brand-Scan of function of x is denoted by Brand-Scan of phi 1, comma phi 2, phi 1, comma phi 2 of x, phi 1, comma phi 2 of x. Okay, page number 94. Page number 94. Page number 194. 194. So theorem number 9.4.6. Do it as homework. Long answer type. 10 marks question. Okay. Next. Next. 9.5. Here. 9.5. Homogeneous equation of order n. 9.5. 9.5. Homogeneous equation of order n. Homogeneous equation of order n. Order n. So in this section, we carry over that has been denoted for second order equation of the form discussed for the equation of order n. We now consider L of y equal to. Consider L of y equal to y power n. Y power n plus a1 y power n minus 1 power n minus 1 plus a2 y power n minus 2 plus so on a and y equal to 0. A and y equal to 0. Consider equation number 1. Consider equation number 1. So here a1, a2 are constants. D equal to d by dx, d square equal to d square y by dx. Okay, earlier we discussed it. Alternatively, you can write one can be written as d of n power n plus a1 d power n minus 1 d power n minus 1 plus a2 d power n minus 2 plus so on an into y that equal to 0, or we can write f of d of y equal to 0, of y equal to 0. So here example, page number 199, page number 199, example 9.5.1, 9.5.1, no, 9.5.2, 9.5.2, both it has 4 mark, important for 10 marks question. Okay, so one theorem and 2 examples, important for 10 marks. Okay. Okay, any doubts? Students, do you have any doubts? Okay. No, I'm leaving.